finally, we have an integration which we have to do by trigonometric substitution. Or by trigonometric substitution is one method which works. It might as well be the easiest. So let's look at the term involving x squared. That's 4 minus x squared. So what do we want to substitute there? We have the term minus x squared, so we want to substitute the sign, and we want therefore to substitute that x is equal to the sine of theta with what factor? The factor is the square root of 4 here, so we get 2 times the sine of theta. So we know that dx is equal to 2 times the cosine of theta d theta. Let's do the substitution. What do we get? We get twice the integral over x squared now is 4 times the sine squared of theta. Divided by the square root of 4 minus x squared, again, is 4 sine squared of theta. Taking the inner derivative, this is already a part of this factor 2, which we wrote at the start, and we get cosine theta d theta. Well, we can simplify that expression. Let's do this. We have in the denominator, we can take a square root of 4 out of, in a parenthesis, and we can take the square root of this. This is 1/2, and that will cancel the square root of 4 is 2. That 2 will cancel with that 2 here. Okay. So we keep a factor 4 in our integral. So let's write the factor 4 here. Now what happens in the numerator? In the numerator we have a sine squared times the cosine of theta d theta. What happens in the denominator? The denominator now is the square root of 1 minus sine squared. 1 minus sine squared is the cosine square, so this is the same as the square root of the cosine square. If we assume we are in the right domain, the square root of the cosine square is just the cosine, so this is the denominator divided by the cosine. Well, what we see immediately is that we have cosine and the cosine numerator and denominator which can cancel, so we have nothing else but an integral over the sine square. Right, how do we integrate sine square? 2 is an even exponent, so we need to use a double angle formula. So what do we get? We get 4 times the integral. What is sine square? That's 1 minus the cosine of 2 theta over 2. So I get 1 minus the cosine of 2 theta divided by 2. Theta, that we see that this 2 will cancel with this 4, making this 4 to a 2, and so we have to integrate 1 minus the cosine 2 theta. Well, an antiderivative of this is rather easy, so we get 2 times antiderivative of 1 is theta, antiderivative of the cosine 2 theta is 1/2 the sine of 2 theta. sine of 2 theta, and we have an integration variable c. Okay, now we need to back substitute. But to back substitute, we need to get terms which are sine and cosine. So let's just observe that this is nothing else but 2 times theta minus 1/2. How do we write sine of 2 theta in terms of sine? Cosine, that is just nothing else but sine of theta times cosine of theta times 2. The 2 will cancel with this 1/2. So we have 2 times sine theta cosine theta, and this 2 and this 1/2 cancel out. Whoops. Color. Okay. Right. Let's make this clean. So we had to integrate 2 times theta minus sine theta cosine theta plus c. Now, what was our substitution? If we look back to the previous page, we remember that our substitution was x was equal to 2 times the sine of theta. So the sine of theta is x over 2, or I get that theta would be equal to the inverse sine of x over 2. Right, what do we do with sine theta, cosine theta? Sine theta is x over 2. For cosine theta, we need to draw a triangle. A triangle for the situation here. So we draw a triangle with angle theta here. The sine of theta is x over 2. The sine is the length of this side divided by this side. So if we set this 2 and this to x, we have the right situation. Pythagoras theorem tells us that the remaining side now has the length 2 squared minus x squared, which is square root of this, which is the square root of 4 minus x squared. So we can read off that the cosine of theta is the square root of 4 minus x squared divided by 2. So we need to multiply our x over 2 with the square root of 4 minus x squared over 2, and then we have an integration constant c, and that's our solution. And that's it for this.